The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, everybody, and thank you for joining us for this afternoon's webinar. Today we're going to be talking about how to choose a microphone 101, give you all the details you need to know on the tips and tricks and the science aspect of choosing a microphone for your application. My name is Cheryl Jennison DeProsa, and I'm joined today by Gino Sigismondi, and we are joined by special guest John Bourne, who is a wired microphone product manager here at Shure. So they're going to talk you all through the different points of how to choose a microphone and the pertinent information you'll need to know going in to make that decision. But before we get to that, just a couple of items of housekeeping. First of all, this webinar will be recorded, so you can always go to shure.com/training and see all of our archived webinars there. There's a lot of great information, so please feel free to peruse that site. Lots of great learning. And then second of all, at the end of the webinar today, if there are any questions, we will get to those, as many of those as we can as time permits. In the right-hand side of your screen, you should see sort of a little toolbox window pane there where you can write in your questions. If you don't see it, just look for the little toolbar with the orange box with the white arrow and click on that, and that will maximize that pane and give you the ability to ask questions. So that wraps up all the business. Let's get into the important stuff. Take it away, Gino and John.
All right. Thanks, Cheryl. Thank you, John, for being here.
My pleasure.
This afternoon. It's good to have you. I guess, as Cheryl said, John is one of our product managers here for wired microphones at Shure, as well as being an active sound engineer in the Chicago market as well. So you're getting the practical experience as well as the product experience here. So it's great to have you.
Thank you.
So what we're going to talk about here today is how to choose a microphone. It's a question that, as you might imagine, we get a lot around here, and there's a couple of different aspects to it. It sounds like a cliche, but it is an art and a science, because one of the things you have to do, if at all possible, is listen to the microphone yourself. I mean, ultimately, what it really comes down to is, you've got to have a microphone that, allows your sound to come through the way you imagine it to, or the way you think it should. And that's something that often you can only determine by auditioning mics. But of course, there's thousands of microphone choices out there, so how could you possibly narrow them down? And that's where the science aspect of it kind of comes in. So what we're really going to try and do this afternoon is go through the kind of sort of mic basics 101, the characteristics that help define microphones. And then in the second half, well, actually probably less than half, but the second part of the webinar, kind of then show you how you apply those different scientific basics, I guess, to the art part of choosing the right microphone. So there's so many different applications, we couldn't possibly get to them all, but at least you can see kind of the thought process that you go into when looking at mic characteristics and figuring out how those might apply to your individual situation. So with that said, let's talk about microphone characteristics. And the first thing we're going to talk about is how the microphone does its job, what its operating principle is, and then we're going to talk about directional response and frequency response, and then some other characteristics that are maybe not quite as important, but still things you should keep in mind, which are the electrical output of the microphone as well as its physical design. So starting with the operating principle, again, this is how a microphone does what it does. And a microphone is a transducer, which is anything that takes one form of energy and turns it into another form of energy. In the case of a microphone, it's converting the sound waves, variations in air pressure that we perceive as or call sound waves, and changes them into an electrical signal, actually a varying voltage. And then that electrical signal can be used for a variety of other purposes, whether it's simply amplifying the sound source to make it louder for reinforcement applications, or capturing it for recording purposes to be manipulated and retransmitted later on, or whatever you happen to need to do with it. The microphone's job is the same in any application there. There are a couple of different ways in which the microphone can convert sound waves into electrical energy. The primary ones are the ones you find most commonly in present-day applications, would be the dynamic microphone, and close behind it, the condenser microphone. Ribbon microphones, which is sort of a close cousin of the dynamic microphone, is also something that was more of a historical microphone that has kind of recently had a comeback and is, we kind of shifted it back up into the primary category there. There are other ways of doing this as well. Crystal microphones and carbon microphones and controlled magnetic microphones and a lot of these other technologies that have sort of fallen by the wayside. You don't really see them, or they're very specialized at least. But for the kind of applications that we normally deal with, it's you're going to be dynamics and condensers with the occasional ribbon mic. So starting with dynamic microphones here, you can see a couple of sort of popular ones shown here, the SM57 on the left and the 55 Unidyne, the actually latest incarnation of it, the 5575 limited edition on the right there. These are kind of, workhorses of the microphone industry. And the 55 is sort of unique in that it, was kind of a groundbreaking dynamic microphone in and of itself. We actually did a whole webinar on that topic last summer. If you're interested in learning about the history of that microphone, you can go look up that webinar. But in any case, dynamic microphones are very popular for a number of good reasons. They tend to be very rugged and reliable and relatively low cost as well, especially when you consider how good they generally sound and how reliable they generally are. But let's take a look here at sort of the technology behind the dynamic mic.
Yeah, dynamic microphones work just kind of like a loudspeaker does, where you have a diaphragm, and that's normally made out of mylar, and it's formed into some shape. And attached to that mylar diaphragm is a voice coil made out of copper or aluminum-clad copper. And that assembly is suspended around a magnet. And that coil fits inside of what's known as the gap, which is in between the magnet and the pole piece. The pole piece is that thing on the right that has those little slots in it. And that pole piece basically directs the magnetic field of the magnet towards the coil. And when you induce that magnetic field across the coil, you get voltage across it, and we can capture that coil. And we literally take the coil leads and route them right to your XLR connector, and you can capture that sound as it strikes that diaphragm and moves that coil within that magnetic field. It's pretty simple and rugged and reliable, and we've done it for a long time pretty well. And the 55 Unidyne, which Gina was talking about, was the first unidirectional dynamic microphone on the market that utilized this principle of using one element to capture a directional source. Prior to that, you had to use two elements and combine them together. So every dynamic microphone today is done like this, based on our design, and every directional dynamic microphone for sure. But it's a pretty down and dirty, easy, convenient way to get audio from the world into an electrical output.
So the pieces that you're seeing here, really, except for like John said, the XLR connector on the output, some of dynamic mics maybe have a transformer in there. That's about all the parts there really are to a dynamic microphone. So, you don't really have a lot of complexity there. There's no active electronics, so the microphone doesn't require any power. There's less that can just go wrong with it, which is part of what makes them so rugged and reliable and environmentally stable and all of that good stuff. And again, also helps contribute to their relatively low cost as well, yet still capture pretty high sound quality. Some of the trade-offs, of course, then would be size. For one thing, a dynamic microphone has to be of a certain size to really sound good, so they can't be effectively miniaturized like you might be able to do with a condenser microphone. So dynamic microphones are, somewhat of a size, and then the coil of wire adds quite a bit of mass to the microphone in and of itself, and therefore dynamic microphones are not as sensitive, again, as compared to other mics like a condenser microphone. So they're not as good for more distant applications. They're more designed with, you can be within a foot or so of the microphone or closer, so that the microphone picks up that sound well.
Yeah, and a dynamic microphone is a perfect accelerometer, so it kind of requires a pretty nice shock mount. They are more prone to handling noise than condenser microphones are. Most of our dynamic mics at Shure have what we call a pneumatic shock mount, which helps prevent significantly reduced handling noise into the product. So the SM58, the SM57, the Beta 58 all have pneumatic shock mounts inside of them, which help reduce hailing noise and stage vibrations from entering your dynamic mic.
And we'll talk a little bit more about sensitivity in a little bit when we talk about the electrical output of the microphone, but that is one way you differentiate microphones is sensitivity, meaning how much output level do you get from the microphone from a given input source. So if you consider, again, when we say a dynamic microphone is less sensitive, again, that means that, it needs to, get hit with a little more signal level to give you a decent output, which is, again, why dynamic mics are great for up-close application on loud sources, loud instruments, loud singers, but maybe not the right choice for when you're miking a choir, for example. Nothing makes me cringe more when I see someone miking a choir with SM58s. Again, if they're up there for the soloist to come right up to and sing, great. But when it's from a distance, the dynamic microphone might not be the best choice based on some of these characteristics. But when you start looking at condenser microphones, now you're talking about a microphone that is much more sensitive than a dynamic microphone and is better suited for distant miking applications. The dynamic mic element also is somewhat limited in terms of the frequency response you can get from the microphone, which is, they sound pretty good, but there's sort of a limit you can hit to how good it can sound in terms of both its naturalness as well as the range of frequencies that it can pick up. And we'll see more about that when we get into frequency response. But the condenser microphone, again, doesn't really have those same sort of restrictions. So there's, as well as a sensitivity issue, there's also a sound quality issue that you can get into with condenser microphones. And let's take a look at the inside of one here.
Yeah, we got a shot of the basic components of a condenser mic. It's also a mylar diaphragm, but normally it's gold sputtered or coated in a conductive material. There's a backplate, which is normally charged either externally or charged in the factory, which would be called an electret condenser mic versus an externally biased condenser mic. But the backplate is charged with a voltage, and then in between the diaphragm and the backplate is known as a spacer washer. It's that thin little ring of plastic there on top of the perforated metal part, and that thing is extremely small. It is about 1/1000th of an inch in thickness, and that's the only distance. That's the only thing between your diaphragm and your backplate. So you can get that kind of what creates the sensitivity, the higher outputs, and we can generally this can scale easily from a large diaphragm down to a small diaphragm down to a miniature 5 millimeter in diameter size. So generally condenser microphones are used for lavaliers and headsets because they can get much smaller than a dynamic microphone can. It does require, though, what's known as phantom power to run a condenser microphone, because there's the output of this cartridge of this condenser mic is very high impedance, and it requires a lot of buffering and circuitry to kind of make the signal usable in a typical XLR output fashion. So it requires circuitry and what's sometimes known as a JFET or a field effect transistor, which helps buffer the sound and get the sound in a usable state. So phantom power is needed for almost all condenser microphones need phantom power to run that circuitry that's involved to get it into a usable signal.
Mm-hmm. And so that electronics, the one thing that you have to be aware of then is that the active components, there's a threshold, a point where they can maybe be overdriven or overloaded by too much signal. So depending on the design of the microphone itself and where its sensitivity is at, you may have to be more aware of things like potentially overloading the microphone. And something I didn't mention about the dynamic microphone, but is an important thing to know about it, is that a dynamic microphone is, I won't say it's impossible to overload it, but it's pretty much impossible by a human, even with a musical instrument, to make enough sound pressure level to overload a dynamic microphone. You pretty much have to mic a rocket ship taking off at very close range in order to create enough sound pressure level to get distortion within a dynamic microphone itself. I don't believe there's a singer on the planet Earth that could actually cause distortion in a dynamic microphone itself. You might get distortion somewhere else further down the signal path in the mixer or somewhere else because of an incorrect gain setting, but the microphone itself will not be overloaded. Again, a condenser mic, it could happen. Some mics have pads in order to be able to deal with that, and you might need to adjust that accordingly, but it is, again, another thing to be aware of on the condenser microphone. Here's really kind of the crux of the difference between the two microphones here. What you're looking at is the measured measurement of a spark gap, so a really quick transient right in front of the microphone, so you can see how the output level varies, or the output signal characteristic varies between a condenser and a dynamic microphone. And you'll kind of notice, because the condenser microphone has so much less mass than a dynamic microphone, it gets moving a lot faster. So if this peak is kind of the peak response at that spark, the condenser mic is coming down almost fully into the negative part of its response, whereas the dynamic mic is still just getting up to its peak. So this is showing that the dynamic microphone takes longer to get going, and then once it does, this kind of ripple at the back end here is showing it takes a lot longer for it to settle down too. So whenever you have something with more mass that is harder to get moving, it's also harder to make it stop moving as well. And so all of this is kind of what leads to that, dynamic mic being not as sensitive as a condenser and not having the same sort of sound quality as well, due to the motion of the diaphragm in and of itself. So this just kind of gives you a visual sort of difference between the two. Again, both sound good. It's just there's a little bit more limitation on the dynamic microphone itself. And then finally, the cousin of the dynamic mic is the ribbon microphone.
Yeah, and a ribbon microphone is generally beloved for its warm sound quality and darkness and richness. And a ribbon mic traditionally it's been a perforated piece of metal or not a perforated, but a formed piece of metal or foil. Traditionally, we use a material called rosalite, which is a nano bonded film. And we use that because it has a much higher SPL. It won't tear. It's much more durable than a traditional foil ribbon would be. But that ribbon is suspended in between two magnets and is exposed on both sides. So you actually get sound in a bidirectional pattern where it can pick up sound in the front and the back equally and rejects from the sides. And ribbon microphones are the ribbon itself is both the coil and the diaphragm in a dynamic mic, and they are great sounding options to tame any sort of harsh sources like a trumpet or a really bright vocalist or a kind of edgy guitar amplifier. Ribbon microphones will kind of tame and smooth and darken and really like nicify, if I could make up a word, nicify the things that are very harsh. They are naturally bidirectional, though, and that leads us into our polar pattern discussion.
Excellent.
About how does a microphone react to sound coming from different angles.
Right. Nice segue. So yes, this is an important characteristic now. So we've covered how microphones kind of work, how they do what they do, but now we're going to talk about how the microphone responds to sounds coming at it from different directions. This is something that you kind of have to, read about or research on the microphone to really know for sure, because you can't tell by looking at a microphone what its directional response is going to be. A lot of people make the assumption, for example, that the SM58 is an omnidirectional microphone because it has a ball windscreen on it, which I guess sort of looks like, a three-dimensional omnidirectional pattern, but that's not true. The SM58 is a unidirectional microphone, meaning it only picks up sound from one direction. So again, you have to look at the actual specs of the microphone, or read. Sometimes it's actually printed on the microphone what its pattern is. I guess that would be one way to tell by looking at the microphone, but you can't just guess. So that's kind of the two broad categories, though, that we have: either omnidirectional, meaning it picks up sound from all directions, or unidirectional, meaning it only picks up sound from one direction. So omnidirectional is great because you don't have to worry about pointing the microphone in any particular way. It's equally sensitive to sound arriving at it from all angles, but that can also be a detriment, particularly in a loud sound reinforcement scenario where you've got, drum kits and guitar amplifiers and all these other sounds on stage. The microphone will be perfectly happy to pick up all of that stuff, which in a more, an environment where you're mixing individual sounds, you probably want to have the microphone just picking up that individual sound. So again, the choice kind of depends on the application, but there are definitely some advantages to omnidirectional mics as well. They don't have any change in sound quality as the distance varies with the microphone. With any sort of unidirectional microphone, you get something that's called proximity effect, which is an increase in bass response as the sound source gets closer to the microphone. Omnidirectional microphones don't have that characteristic. And again, that characteristic is neither good nor bad. In fact, some people actually happen to like what it does to their voice when you get bassier as you get close to the microphone, but it's just something to be aware of as a difference between the two. Omnidirectional microphones are also less sensitive to things like wind noise and handling noise and other anomalies that you don't want to be picked up. But again, on the downside, they do pick up everything, and that can also be problematic in loud environments where feedback is an issue, since the microphone isn't discerning it all from any direction. Doesn't matter which way you point the microphone, it's going to be perfectly happy to pick up the sound from the loudspeakers, which could lead to a feedback loop as well. So that's also something to be aware of. So in recording applications and broadcast applications, omnidirectional is totally fine. You don't have those concerns. In the large percentage of live sound reinforcement scenarios, it's probably more likely going to be unidirectional microphones, except for a case of like maybe musical theater or something like that, where you've got head-worn microphones that are very close to the mouth. Then the gain before feedback issue isn't as much of a problem, because if you've ever attended our webinar on how to maximize gain before feedback, you know that keeping the microphone close to the sound source is the best way to maximize that. And so a head-worn mic's very close to your mouth, so you can get away with an Omni, and it works well in that particular scenario. And then we have cardioid pattern mics.
Yeah, directional microphones. Cardioid is the most common for sure. And we say it's cardioid because it is shaped like a heart, cardiovascular. Looking on the graph on the right, that's a top-down view. So 0 degrees would be on axis, or the front of the mic, and directly behind the microphone at 180 degrees is off axis, and that's where you receive the most amount of rejection on a cardioid response to microphone. I would say 50 to 75% of all unidirectional microphones out there are probably cardioid. And there's a reason for that. They're forgiving on their on-axis performance in terms of if you want to sneak maybe 2 people on a cardioid mic, you probably can. You can get away with it. You lose about 6 dB, which is a noticeable change on the sides of the mic, so at the 90s, and then you get the most rejection in the rear. So a great solution for a lot of applications that you'll find on stage and in the studio too.
So again, the advantage is, you pick up what the microphone is aimed at and a lot less of everything else. And as John mentioned, it's a good compromise between some of the other directional patterns, which get more and more directional as you move to the right on this chart, starting at Omni. Each pattern here, you have more and more off-axis rejection, which means that you have to be more and more concerned, particularly in like a handheld application, of making sure that you stay in front of the microphone, because the response starts to drop off more dramatically as you get from supercardioid to hypercardioid. A trade-off you might note, though, is that as you get more or increased rejection at the sides of the mic, you end up with a little bit of pickup at the back of the microphone. It's kind of like squeezing a balloon in the middle or something. You start to get one side gets smaller on the top, means it has to get bigger on the bottom, so you end up with a little bit of pickup at the back, and that gets even more extreme at hypercardioid. And then keep going, and eventually you end up at a bidirectional microphone then, where your greatest rejection is at 90 degrees off axis, and the pickup at the front and the back is actually equal. That's when a bidirectional mic like the ribbon microphones, the kind of pattern that they actually happen to have. So again, it's all about trade-offs. So one thing to watch out for is if you give a supercardioid microphone to an untrained user, then you have to worry more about, as they start moving off to the side of the microphone, it tends to, the response, the pickup will drop off a lot faster. So for untrained users, maybe they're better off with a cardioid, or maybe you just like to be able to have a little bit wider working range as you're using the microphone. Or maybe you don't want to deal with this lobe at the back, which gives you a little bit of pickup and impacts stage monitor placement. All of these things are important things to consider when you're thinking about the different pickup patterns of the microphone. And some microphones even have switchable pickup patterns, which is a nice feature. Sometimes you can choose between omni or cardioid, or cardioid and supercardioid. These are all features to look for and think about. So now we're going to move into a frequency response of the microphone, which is basically how it sounds. But that can be plotted on a graph. Now, does that tell you everything? I mean, it can give you an idea of what the microphone sounds like. It's still not the same as actually listening to it. But on any frequency response chart, what you're looking at is along the horizontal axis is the range of frequencies that humans can hear from 20 hertz to 20,000 hertz. At least when you're a newborn, you can hear that. I don't know if we can hear that anymore.
Definitely
but
not.
at some point in our lives, we could. And then on the y-axis, you're looking at the measured output level of the microphone at those different frequencies. So when we talk about a microphone having flat frequency response, that basically means that this microphone at any given frequency, the output is mostly the same, or so it ends up looking like a flat line. So this is very natural, very wide-ranging frequency response. It's not going to color the sound. It's not going to change the sound. It's going to pick up pretty much everything equally, versus shaped frequency response. Again, it should be pretty obvious why we call it shaped frequency response, but now what you can see is that at different frequencies, the output level or sensitivity of the microphone changes. So this particular microphone is less sensitive at lower frequencies and actually more sensitive or has higher output at higher frequencies. So you're actually getting a boost in a certain range here. And you might look at that and think, well, wouldn't you always want this? Isn't flat frequency response the best if it's natural and picks up everything? Well, you might not necessarily want to pick up everything. If you consider the sound source that you're trying to pick up with the microphone, you have to look at the range of frequencies that particular sound source is capable of producing and pick a microphone that picks up that range. And unless you're doing like a giant pipe organ or maybe a grand piano or something like that, you really don't need a microphone with 20 to 20,000 hertz response. If you pick up a lot of low frequency, if you have a lot of low frequency response that's not needed, then you might end up just picking, wind noise or handling noise or stage vibration, things that you don't want. That all tends to be down here in the lower part of the frequency range. So using a microphone that kind of naturally rolls all that stuff off will actually clean up the sound and make things better. So if this were a vocal microphone, it actually is a vocal microphone, this would be perfectly fine, because unless you're the bass singer in a gospel choir, you probably don't need any frequency response, or at least not much below 100 hertz. So this kind of roll off is beneficial, and you're not really sacrificing anything. And then as it turns out, up here in the 2 to sort of 5, 6K range, this is what we refer to as a presence peak. What this is doing is boosting the response of the microphone in a range where consonant sounds are, and consonants are what is important to intelligibility and understanding what's being said. So this is actually the response of the SM58 dynamic microphone, and part of the reason it's been so successful is because of this presence peak right here. When rock bands started getting louder and louder and guitar players started turning up more and more, in order for the vocals to cut through, it really helped to have a microphone that kind of already was boosting this range and helping increase intelligibility. And then again, above about 10K or so, there's not a lot in the human voice really happening there, at least especially not that's as far as important to intelligibility. In a recording application, you might want more stuff happening up here, but in a live sound application, it's pretty much unnecessary, so this tends to work. And this tends to be pretty typical of what you can achieve with a dynamic microphone. This sort of flat frequency response, you really can't get there with the condenser microphone.
Yeah, condenser mics tend to
with a dynamic mic, sorry.
Yeah.
You can with a condenser mic.
Yeah, condenser microphones tend to be more in the flat response nature, and dynamic microphones, just by physics, it's very difficult to make a flat sounding dynamic mic. It's just physics doesn't allow you to do that very well. So, because you have three things to work with, and you're talking about manipulating air volumes and resistances and parts and diaphragms, and so shaped response microphones tend to kind of be more in the dynamic realm, and flat response microphones tend to be more in the condenser realm.
You can have shaped response condenser microphones, and they often are shaped that way for particular applications, maybe, or to emphasize, again, a particular type of sound source. But the opposite is not true. Dynamic mics, this sort of flat frequency response that you can achieve with a condenser microphone, you pretty much can't get there with a dynamic mic. So also something to think about. We won't get too much into electronics here, but you do have to consider the electrical output of the microphone, because it does impact what you're connecting it to. you really do need to kind of keep just a couple of basic things in mind here. And part of it depends on whether or not it's going to be an analog or a digital device that you're ultimately connecting to, because a lot of people are podcasting or doing recording on computers. And if you're connecting the microphone to the computer, what does that mean versus just, say, plugging it into an analog mic mixer or something with analog mic inputs? Probably the most important thing to consider is, again, the sensitivity of the microphone, which we mentioned earlier. Again, sensitivity is it's a measure of voltage based on a kind of a known given input source. I mean, there's all kinds of signal levels you could put into the microphone, but you have to sort of pick one to measure against. But then once you've defined what that kind of input is, that allows you to sort of decide or see here what the output level of the microphone might be. And so we've labeled a couple on here. We've got an SM58 dynamic microphone and a KSM44A condenser microphone. And you notice in this case, the difference between the two is about 20 dB. Now, that doesn't necessarily go for all condenser microphones. They're not all 20 dB more sensitive or 25 dB more sensitive than a dynamic microphone, but they could be. KSM44A is a pretty sensitive microphone, but something like a Beta 87 that's designed for up close handheld vocal use like an SM58, its sensitivity might artificially be manipulated to be closer to an SM58 or maybe just a few dB more sensitive. So there's really no standard that says all microphones have this exact same sensitivity. There's kind of a range. But the important thing to note is that a mixer's output level is going to be more what we call line level, which is 50 dB hotter than an SM58, right? So what that means is that that's why you have to plug a microphone into something that is labeled microphone input. You can't plug a microphone directly into a power amplifier that's looking for line level from a mixer because there's not nearly enough signal level there to drive it. And this also becomes important when you're looking at interfaces for computer recording, which we'll see a couple examples of in a minute here. But you need to make sure that if you're using a low sensitivity microphone like the SM58 or even like an SM7, which is even lower than a SM58, that the device you're using for amplification has enough amplification to get that signal up to the sort of line level signal that we're interested in. So it's important to at least keep that in mind. The impedance is not as much of a problem anymore because pretty much all professional microphones are what's called a low impedance output, and all professional audio inputs that you might connect them to are designed to accept low impedance microphones. Again, if you happen to have some old mic from the 80s that's a high impedance mic and you plug it into a low impedance mic input on a newer mixer, you might have some problems with signal levels there that you need to address with a transformer or something like that. But in general, anything you're going to go to the store and buy today, it's probably going to work okay unless you're trying to plug it into a computer. Computer audio inputs, like you see labeled here, are not really what we would consider a professional microphone input. They're wired differently, impedance is different, signal levels are different.
They're pretty much horrible. Don't use them.
Right.
We really don't recommend it. The 1/8 inch input on a computer that says either a mic in or a line in are like, if you just want to actually don't use it. Don't even use it for that. Don't even use it for anything. So this is where we really advise going towards a USB output microphone or using the USB port in an interface. And we'll talk about some of the options out there. So it'll take your XLR inputs and through an interface and give you and do all the conversion, all the analog to digital conversion externally outside of the computer, because everything that's inside the computer is basically the lowest cost manufactured thing that they can come up with. So if you want any sort of decent, good audio quality with low noise, which is important, and high signal output, you're going to want to go to an interface or to a USB product that has all that stuff built into it. We have a couple of great options out there now for USB offerings, and also to go into your iPhone or iOS products. We're coming out with a couple of those. But the key to when purchasing a USB product or a USB interface is to make sure you have a headphone port, a headphone jack on the actual interface. That allows you to monitor the incoming signal directly before it goes to your computer. And that's important if you're going to do any sort of overdubbing or singing or talking to a track or doing any sort of multi-tracking scenarios. You want to be able to monitor the incoming signal before it hits the computer, because if you try to monitor after it goes into the computer, you're going to be hit with all these latency issues or delay issues where you're not quite in sync. And it's going to sound like you're in this weird tin can because everything is delayed by 50 or 100 or 200 milliseconds. It's going to be really annoying. So all of our products all have headphone jacks on there for a reason, so that you use them and you can monitor the source before it goes into your computer, and you don't have any of these latency issues.
So this is a great solution here for if you only need to record with one mic at a time because you're a podcaster or you're just a solo singer-songwriter kind of making demos at home. But as soon as you need to plug multiple microphones into your computer simultaneously for multi-track recording, then you might want to get a recording interface that connects to your computer, again, via USB or FireWire. And then you have analog mic inputs, hopefully with phantom power on them if you're using condenser microphones. I think most of these things do have phantom power these days. And then these, again, will do the same function, but allow you to use multiple microphones connected to your computer. And finally, don't forget about the physical design of the microphone. There's not a lot to say about this other than be aware that microphones do come in all kinds of different shapes and sizes, including some very specialized mics for specialized applications like clipping onto the bell of a saxophone or something like that. Or, they're small and they're large and they're handheld and they're stand mounted and there's head worn, and there's all these different physical designs out there that, you just have to pick the one that suits what you need it for your particular application. And speaking of applications, let's go there now. So that, again, those are all the characteristics that really define microphones. So let's, again, just picking a few examples here, let's see how you might apply those and think about how they impact what you're using them for. And we're going to start with one of the most common uses for a microphone, which is
the vocal mic.
The vocal mic.
So you have a singer like this.
Like I've seen her somewhere before.
You should
Who is that crazy lady?
You should step back from the speakers a little bit more if you're gonna be listening to this one, because it's gonna get loud. So Gina, what kind of microphone is this?
That's a wireless version of an SM58. Why are we using an SM58 for singing? Because it's a dynamic microphone that can handle extremely high sound pressure levels, like I'm sure is being generated here.
Yes.
And it has a nice directional pattern, so you're not picking up all the noise from that drummer that's on stage and the guitar amps that are off to the left and the right and all that other good stuff. Now, is that the only choice we could use? Of course not. There are many condenser microphones that are also designed for vocal and singing applications as well. But again, if you're on maybe a quieter stage or you're trying to pick up the subtleties of the vocal performance, or maybe it's more of like a jazz or again, a singer-songwriter type application, maybe that's something that has more of that extended high frequency response and more natural response might be important. But the SM58 presence peak is definitely going to help when you're singing Iron Maiden songs.
Yes.
So you do have to kind of consider the whole application and then kind of, apply that to which of those types of characteristics are going to be best suited. In this type of application, maybe even a mic with a supercardioid or hypercardioid pattern might be more appropriate, because it's going to pick up even less of that stage bleed, the on-stage noise. So those are, again, the kind of things that we're talking about here. The things that we can rule out: this application, you're not going to use an omnidirectional microphone. Probably not too many ribbon microphones that are suited for this either.
Mm-hmm.
So.
But on the other hand, I have seen KSM44 large diaphragm mics used on stage for like Nashville and bluegrass stuff.
Certainly.
And I've seen SM7s used as vocal mics. And so, it all kind of depends on your form factor and what's going to drive that. But I'd say typical handheld applications, you're going to fall into this vocal.
Right. Unidirectional, cardioid, or condenser if it's designed to handle the up-close sound pressure levels that you need here. Mm-hmm. And this is kind of a live sound application. In recording, you might have a different set of requirements. In fact, in a recording application, you probably wouldn't want to use a handheld microphone, because all handheld microphones, even ones with really, really good shock mounts, there's still some chance that you're going to get some handling noise, which in a recording application could ruin the take. In live sound, it doesn't really matter so much, but in a recording application, you don't want to take ruined by the singer tapping their hand on the microphone. So you're going to more of a stand mounted thing, where maybe the large diaphragm type condenser microphone becomes more of what you might choose for that application. Maybe even an omnidirectional mic if you're in a good sounding room. But if you're recording in your closet at home, well, who knows what kind of reflections, again, you want that directional pattern to help you out in that application. Speech is also another type thing that you might need to record or capture as well.
Yeah, and so podcasting is is going well now with a lot of people and very popular. And so we have a couple great USB offerings now. Generally, if you know you're going into a computer and that's all you want to do all the time, going with the USB microphone or any iOS microphone is going to be the way to go. So generally, our USB offerings are condenser microphones because they're a little more sensitive. You can get further away from them and still get nice clarity and pickup, and they sound really good. They're easy to use, and they all have direct USB outputs on them, and with mic gain and headphone out and all that stuff. So they all have stands on them now, so you can just sit on your desktop real easily. So podcasting, we have some large diaphragm and small diaphragm offerings, which we'll talk about the differences in the next slide or two.
Let's talk about electric guitar for a minute. Again, as you can see from what's pictured on the slide here, either dynamic or condenser microphones can be appropriate for this situation. Again, one thing they're all going to have in common, though, is they all are some sort of a directional pickup pattern, because if it's being used in a sound reinforcement or even a recording environment, depending on how you're recording, you might not want to pick up a lot of everything else that's going around. Plus the proximity effect you can take advantage of here when the microphone is nice and close to the sound source. One thing you do want to look out for if you're using a condenser microphone like you see here, the KSM-44A is a pretty sensitive microphone, but it also has a pad that you can kick in, which makes it then appropriate for use up close on an amplifier like this, versus say like we have a KSM like 42, which is more designed for vocal applications and doesn't have a pad on it.
Mm-hmm.
Maybe that wouldn't work as well on your guitar amplifier then, because you might hit it with way too much signal when it's pressed up against the speaker, just like that is. So those are things you need to be aware of if you're going to choose a condenser mic for this application, is make sure it has sensitivity, or at least adjustable sensitivity, that make it work for that particular situation.
Yeah, a lot of people like double miking electric guitars too. So they'll mic with a dynamic mic and a condenser microphone. They get the two different tones out of the same guitar amp because you can blend the two later. So and ribbon microphones are also very, very nice on guitar. They take the edge off. They smooth things out. They warm things up. So ribbon mics are also a nice option, especially our ribbon mics, because they have a much higher SPL handling capability than older traditional ribbons do. So ribbon mics are also nice.
Yeah. Again, probably not looking at omnidirectional mics here, but if you are in a recording application in a good sounding room and you want to pick up more of that sound of the room, then maybe you might choose an omnidirectional mic here. But, and again, in most cases, it's going to be more of that cardioid type pattern on the guitars here. And again, the dynamic mic with that shaped frequency response does tend to lend it well, particularly to distorted, rock guitar sounds. That's why the 57 is so popular for that. But if you want something a little wider ranging and more natural and picking up more subtleties, again, the condenser mic can help with that, or the ribbon mic to kind of darken up the sound. Now, speaking of condenser microphones, it is worth noting that there are what are sort of categorically described as large diaphragm and small diaphragm condenser microphones. And even though this isn't officially sort of codified or anywhere, we typically think of a large diaphragm microphone as being like about a 1-inch diaphragm. Small diaphragm could be anything smaller than that, but usually say a 1 centimeter or smaller cartridge would be a small diaphragm microphone. And sometimes, if you read a lot of forums and things, you might start to get the impression that, well, geez, I really need a large diaphragm condenser microphone, but that's not necessarily always the case, right?
Yeah, not totally true. It kind of depends on, like everything in audio, it depends on what you want to do with it. So large diaphragm mics generally do, because they have a larger surface area on the diaphragm, you can get a higher output level. So the sensitivity is generally higher on large diaphragms. That's why you'll see pads on a lot of large diaphragm mics to be able to handle high SPL applications. But actually, smaller diaphragm mics, like a 1/2 inch or a 3/4 inch diaphragm, will actually have a wider frequency range than a larger diaphragm mic will. And also the biggest thing to know is like off-axis consistency, or the directionality effect, is less. So microphone obviously captures what you're pointing it at, but also captures everything else in the room at a reduced level, but it also still captures it. So smaller diaphragm microphones tend to be favored for recording, like larger ensembles or orchestra mics or anything that you want a cleaner off-axis sound. The reason for that is a smaller diaphragm mic is smaller and has less reflections around it. And when you stick a large diaphragm microphone inside of a cage and you're addressing it on the side, most likely you get a lot more reflections in that pickup of the mic, and it tends to be not as clean as you will off axis in terms of the image that you get. So so small diaphragm microphones tend to be a little bit more consistent in that respect.
I think it's important to understand too that size doesn't matter when you're talking about needing to pick up low frequency response. There's often a misperception that large diaphragm mics have better low frequency response because they're bigger and they're therefore bigger at picking up longer wavelengths. But the ability of a microphone to pick up certain frequencies has nothing to do with its size when we're talking about condenser microphones, and very tiny condenser microphones can still be very good at picking up, sometimes clear down to 20 hertz or so. But the large diaphragm microphones, they actually tend to be less sensitive at higher frequencies maybe than, or at least less linear than a small diaphragm mic might be. So there's a perception then that they sound warmer or darker, and it's really because of that reason, which for certain vocals or certain guitars might be what you want, and that might be the sound that you're going for, and that would be an application for a large diaphragm microphone then instead. So when you're looking at things like acoustic guitar, now we're starting to get into things where really condenser microphones start to become the primary choice. Again, because you're miking from more of a distance, because you're picking up a sound source that you want to try and capture more accurately, the characteristics of the condenser microphone start to become more important. Could you mic an acoustic guitar with an SM57? Sure you could. It might sound pretty decent.
Probably happens every day.
Probably happens every day. But you want to go for the best possible sound quality that you can capture. The condenser mics, large or small diaphragm, depending on the sound quality that you happen to personally like, either one could be appropriate there. So that's where you start getting into that. And again, normally going to be cardioid if it's any sort of a sound reinforcement or a noisy room recording. Maybe you might get Omni. It really just kind of depends on what you're doing there, but definitely more of a condenser mic application, as it would be for grand piano as well. Again, you're talking about a very wide frequency range that you need to pick up here, and that type of, again, if it's a good sounding piano and you want it to sound like the piano, then you're probably not going to put an SM58 inside of there, right? You're going to want something that is more wide ranging and more natural sounding to pick up the sound of that instrument, and that really applies to also any kind of ensemble as well. I mean, we don't have a slide for it here, but when we're talking about acoustic ensembles, an orchestra, a small chamber group, a string quartet, a brass quartet, whatever it happens to be, you're more at a distance, you're trying to pick up the whole ensemble and the whole range of sounds that ensemble is creating, you're really looking at condenser type microphones with flat natural frequency response for that application.
Yeah, for grand piano, for me, it all depends on what instrumentation is around it. Is it live or is it in the studio? Can you control the environment? Because it's such a big instrument. If you want to record a piano that, in the studio and that's all you're recording, awesome. You can put that mic wherever you want. But if you're on stage and you got a drum set inside the curve of the piano and you're trying to get as much gain out of that microphone as you can, you're going to be trying to get that thing really close to the hammers and get it really close mic'd and try and get the lid closed and using blankets. So it's all comes down to kind of your environment and what is around that piano.
Mm-hmm. So I want to make sure we have time to get to a few questions. So I'm going to kind of breeze through drums here because drums is sort of a complex topic, because when you're miking a drum kit, you're not miking an instrument, you're miking several instruments all in very close proximity to one another. Now, what that helps you think about, though, in terms of like directionality, can be a huge advantage here. That's why like a lot of our original drum mics were available in the beta series dynamics with super cardioid patterns, right? So you can get a lot of mics in a small amount of space, but not be picking up a lot of the other drums that are close to it. And again, dynamic mics are great in applications where the sound pressure level is very high, which of course it is when you're inches from a drum head or millimeters sometimes from a drum head. Now, again, there are condenser mics that are specifically optimized for close miking on drums, and that's where that sensitivity specification comes into play again. You want a microphone with lower sensitivity that can handle being that close to a drum. In fact, skipping ahead to the tom-toms here, this is a condenser microphone, the Beta 98A, that is specifically optimized to be right there, right close to the drum. Would you do that with something like a KSM 141 condenser microphone? Probably not, although that mic does have a 25 dB pad on it, so maybe it could handle it if you did that. But those are things that you need to consider when you're miking drums, is being able to handle loud sound pressure levels and being directional enough to only pick up the drum that it's in front of. And then there are, again, something to go back to the kick drum again, the Beta 52 here, its frequency response is specifically tailored to be optimized for sound quality that is designed for drums. Again, it's not a kick drum mic because of the way it looks, although that's the way most people kind of think a kick drum mic should look. But it has the sound signature that you need for that application that makes it pretty specialized for that. I don't know a lot of other instruments you might use that microphone on other than the kick drum because of how it's specifically tailored. And again, overhead microphones on drums, condenser microphone picks up the high frequencies of the cymbals very well, and you can get away with things that are a little more sensitive because they're elevated and a little bit further away. Some additional resources you might want to investigate, because we're really just kind of scratching the surface here, are the Shure blog, which has, if you go under topics and education, you can find all kinds of great blog posts, many of which the images for this webinar were stolen from our blog, so you can find all kinds of good stuff there. Our YouTube channel, youtube.com/Shure Inc. has a playlist of educational videos. Particularly good ones to look at are Understanding Mic Specifications. It's a 4-part series that covers all of this stuff. We have a mic listening lab on our website where you can go hear the microphones on various sound sources in various positions, which really helps as well. And then don't forget about our training website as well, where you can find webinar archives and links to some educational publications that are really useful for learning more about this topic. So as I said, we just kind of scratched the surface here. But ultimately, as I said, it's your choice. If there's any way to audition the microphones and actually get a chance to listen to them, that's how you're going to know the best. All of these other things we talked about help you narrow the field down to get down to something that you really have to try out and find the one that's going to work best for you. Cheryl?
All right. We don't have too many questions, so we'll just kind of go through these here. If you have any, please get them in now. The first and only question I have right now is asking if you could touch on improper and proper on-axis mic technique, i.e. cupping the microphone.
Oh, great question. You want
Don't cup the microphone.
There you go.
Done.
But why, John? Why shouldn't you cup the microphone?
So all directional microphones have side entry ports. So we basically every microphone, except for ribbons, but every microphone wants to be an omnidirectional microphone, and we do a whole bunch of stuff to break that and turn it into a directional microphone. And the way you do that is you allow sound to strike under the diaphragm, as opposed and along with on top of the diaphragm. So we do that through these side entry ports. And if you pull off the grill on an SM58, you'll see this perforated metal slit around the side of it, and that allows sound to strike under the diaphragm. When you close those ports off, you're essentially turning it into a really bad omnidirectional mic. Along with
pseudo-omni.
It's like because if you were close those ports off completely, you basically can turn it into a decent, okay omnidirectional microphone. But in that process, you also make the sound horrible. It gets really nasally and thin sounding, and so basically keep your hand off the grill on any handheld directional mic, and you will thank your engineer will thank you, and you will thank yourself, because you will sound better for your audience. You will have more clarity. You won't have as much feedback because you're not turning your microphone into an omnidirectional microphone, and it's just overall just a really bad technique to get into.
Everybody does it.
Everybody does it because you look so cool, man. When you
Don't do
you
it.
just can't hear myself.
Be a trendsetter.
Okay, now we've got some more questions. What effects, good or bad, do windscreens and pop filters introduce to the microphone performance, and when should you use such devices?
Well, windscreen, I mean, it serves a very specific purpose, right? Directional microphones, omnidirectional mics are great because they actually don't need windscreens as much as unidirectional mics do. But unidirectional microphones are much more sensitive to wind noise, and that's partially due to the porting that John mentioned when we talked about how we make a microphone be unidirectional. So wind blows across it, and you get that really horrible, rumbly sound. So you put a windscreen over the microphone to try and reduce that. Some mics, like the SM58, actually have sort of a built-in windscreen that is, there's a foam underneath the metal mesh windscreen as well that provides layers of protection. But sometimes you need to add any more. What you have to watch out for is the more material you put in the way, it can start to affect the high frequency response of the microphone. So that might be a trade-off that you'd have to watch out for.
Yeah. In general, though, if you are outside, the trade-off of having less wind noise in your microphones is better than the high frequency loss that you may get when you start sticking very thick windscreens over top of your bog grills and stuff like that.
All things in audio, it's a trade-off or a compromise, and you have to take the lesser of two evils.
Yeah.
What about pop filters?
Pop filters are very similar in their fashion. You know, it's almost like a windscreen. You could kind of, they're interchangeable in some respect. But pop filters, when we say pop, we mean, I will attempt to pop this mic. It's the pop you get when you say peas or cheese, and you'll get this big puff of air that goes into your mic, and it will kind of sound weird. Pop filters, the pantyhose style like pop filter you might see, our PS6 is what we call it. For studio, there's very little effect on audio quality when you use those types of pop filters in the studio. You would definitely receive the benefit of blocking those plosives before they hit the diaphragm. And a windscreen, traditional windscreen, will also help you get less pops in your mic as well. And that's why you'll see those on like announcement mics or TV host mics. You'll see a windscreen on top of the grill to help with plosives.
A little known trick that a lot of people don't know is, rather than employing a pop filter, if you actually hold the microphone or put the microphone at more of an angle to the mouth instead of directly in line in front of your lips, that will actually help minimize those plosives. So rather than going again right into it, go a little off to the side, and then the breath blast will go past the microphone instead of right into it. And then you may not even need a popper stopper just by changing the angle a little bit.
Mm-hmm.
Here's a really interesting question. You talked about reliability with the dynamic mics. Do condenser mics need to be replaced more frequently? And how long would you consider the quote unquote life of a microphone to be?
Well, I would say traditionally condenser microphones used to be not as rugged as dynamic mics. I would probably buck that myth and say all of our condenser microphones that at least we make here at Shure are equally as rugged as our dynamic microphones are. From a corporate quality standpoint, just because we make a condenser microphone doesn't mean we lax our quality standards. So a KSM44 studio microphone goes through the same drop test and moisture resistance and humidity and hot and cold storage that the SM58 goes through. So I would say that's probably one of the benefits you get when you purchase a Shure mic, is you're buying that rugged and reliability regardless of what kind of microphone you choose.
Now, if you have some sort of vintage tube condenser microphone from the 1940s, do you have to be a little bit more careful with something like that? Absolutely. But we're talking about, modern, newly manufactured condenser mics.
Yeah, if you drop your KSM44, it's not going to break. If you drop your KSM ribbon, it's not going to break. It's they're just as rugged in general as our dynamics now.
We actually just recently added a YouTube video to our YouTube channel. If you visit the Shure YouTube channel, where we do show you some of the testing we do with our ribbon microphones, and you'll see drop tests with those, and you'll see one in front of a bass drum, and it's actually really interesting. So
there's some cool slow-mo video on that one. That's nice.
Mm-hmm. Okay, what kind of microphones would you recommend for doing radio spots?
You say radio, I say SM7.
That was easy.
That's pretty much the de facto radio broadcast mic of the world, I would say. The SM7 and the RA20 are both great options, but we're obviously a little more favored towards the SM7 because it's our microphone. But that's our biggest, best sounding dynamic mic that we offer. And actually, we talk about shape versus flat response. The SM7 has a very flat response for being a dynamic mic. And that's pretty much why a lot of people love it as a better alternative, or a different alternative to condenser microphones.
If you're looking for more of that kind of traditional FM radio DJ smooth sort of a sound, the SM7 just has that kind of sound quality, that darkness to it, that a condenser microphone is just always going to be a little more little
Shrill.
zippier, a little brighter, a little more shrill that you may not want for that specific sound. So again, that's why being able to hear these mics becomes such an important thing.
On the condenser side, the KSM42 is a great option. It comes with a magnetic pop filter that fits right over the shock mount, and it's it's voice tailored for voiceovers. So they're both great options.
Okay. And then just one last question here. We have time for one last one. Omnidirectional is better for rejecting wind noise. However, this causes issues when the user is in front of the sound system outdoors. What lav style microphone would you recommend to offer the best both wind rejection as well as being directional?
Lavalier mics and wind is a constant problem outdoors.
You need a big windscreen.
You need a big windscreen, and you need a directional lav, and that brings other challenges too with people moving their heads back and forth. And I would say, if you can convince somebody to use a headset microphone over a lavalier microphone outdoors in a PA system, you're going to be much better off with just gain before feedback and wind reduction. But our WL185 lavalier is a directional 1 centimeter lav that comes with a windscreen. And outdoors on a lav, you're going to most likely want to pick up some additional wind protection. You're not going to want to go to Omnis because you're going to have gain before feedback issues. But you're going to Rycote is a RYCOTE is a company that makes additional wind protection for our products as a third-party accessory manufacturer that is really good and well respected in the industry. And you can pick up little mini furries that can slip over our windscreens to give you even more wind protection on a directional mic outside.
Fantastic. All right. Lots of great information. We hope you learned something today. Please join us next month. We're going to be talking about a very hot topic as per usual, feedback. So please keep your eyes peeled. We'll be having that. Do we have the date for that one yet, Gino?
We had the date of June 29th.
June 29th. Great. Shure.com/training